All right, I think we should be good to go. Jamie, you ready? Awesome. All right, well, hi folks. Thank you all today for joining us on this fun Thursday as we discuss how to untangle the data mesh to enable domain-driven analytics using SMALT. Today, your speakers include myself, Osuna, and Jamie Laird. To provide my personal background, I am a principal data engineer based in Houston, Texas, while my dear teammate Jamie is a principal analytics consultant residing in London. Please feel free to connect with us on LinkedIn. We love expanding our network of analytics professionals and being a part of a community that is equally as passionate about how to make analytics more accessible for everyone. And Jamie and I, we're just two members of the Aimpoint digital team focusing on providing end-to-end analytics strategy, enablement, and development services for organizations from all industries and of all sizes. Our areas of competency range from analytics, automation, and visualization to predictive and prescriptive analytics, and all the way to the architecture and development of the analytical layer and other data infrastructure. Aimpoint Digital has close partnerships with industry-leading analytics software companies, and today we're going to discuss 4 of our partner platforms that make up SMALT. So, what does SMALT stand for? Well, S is for Snowflake. Snowflake is the market-leading cloud-native data platform solution and also usually a de facto component of the modern data stack. M is for Matillion, a graphical ETL tool that was purpose-built for the cloud and natively integrates with Snowflake, as well as with all the other public cloud data warehouses. AL, or ALL, is for Alteryx, a unified analytics platform for automating processes from data discovery to data transformation and even machine learning and text analytics. And lastly, T is for Tableau, the market leader in visual analytics, helping folks derive insights from their data through an interactive drag and drop interface. Well, now that we've introduced the SMALT stack, let's dive into the details of what the data mesh is, how it addresses current pitfalls that we've seen in our experience serving clients, as well as how analytics fits in the whole picture. So, first, I wanted to highlight a quote from the article that spurred this whole data mesh madness from the author herself that I think really encapsulates the overarching theme of our presentation. Zhamak Dehghani states, "Self-serve infrastructure must include capabilities to lower the current cost and specialization needed to build data products." And I can't stress enough how important this has been in my personal experience working with businesses of all sizes who want to be more data-driven through self-service analytics, but have generally struggled with the high demand and low supply of hiring specialized analytics professionals, as well as in justifying the cost of investment into developing data infrastructure. So let's talk about what challenges that we've seen with our clients as they've been working to develop a data platform that fits all of their analytic needs. In recent years, there has been a major push for organizations to be more data-driven by centralizing all of the data into one monolithic architecture that has been developed and maintained by one central data team. But has this been effective? You know, some of the common challenges that we've seen as a result of this framework include organizational bottlenecks as the central data team that's usually a group of hyper-specialized data engineers. They're overwhelmed with wrangling all of the data sources that are proliferating and all of the analytical needs that are popping up from every consumer in every domain. And this same data team is often siloed from the operational teams that actually generate and consume the data, which leave the data team disconnected from their customers. And more frequently than not, the data team lacks the domain expertise or access to the domain expertise needed to understand the application of the data that they're working with, which makes it difficult to develop meaningful data models efficiently. So as a result of all this constant firefighting, the central data team generally has difficulty prioritizing the efforts that are needed to bootstrap the platform in order to even get self-service analytics going, or to enable generalists to engage in analytics. So all of that does not lend itself to a scalable model of analytics, as often the data team is overstretched and they're in a tight spot just trying to make everyone happy while also having to prove value quickly so that they can justify hiring further resources. So to make this point further, I'm going to walk through a scenario that we've likely all experienced to some extent. So here we have our typical setup where we have our domain experts generating data, usually the way that they've always done it, while pushing a lot of the transformation and standardization to the central data team to handle by building data pipelines, which ultimately yields some form of an analytical layer for data analysts to self-serve data and to produce analyses to answer the business questions. But more importantly, everyone's happy. Yay. But what happens when there's a change in the data that occurs upstream and that this change may not have been well communicated downstream or could have just been missed entirely? Well, usually the data analysts are the first to notice something fishy going on with their analyses, and they're annoyed with what they perceive to be untrustworthy data. So they go to the central data team angry and frustrated and demanding answers. So then the central data team, they might not be able to look into it right away because they're busy dealing with other pressing matters and issues that are going on with other domains. But eventually, when the request makes its way from the backlog into their hands, the data team might find some unforeseen schema change that nullified their pipeline. And now they're also angry and frustrated. So they go back to the domain experts, demanding answers. And then lastly, the domain experts, they're busy dealing with the day-to-day operations, and usually they don't even get to participate in the analytical applications of the data that they produce. So they don't feel the urgency to dig into the data and understand what changed. So they usually start pointing fingers back at the data team. So all of this leads to time wasted and to a data team that feels underappreciated and overwhelmed. Does this sound like a familiar scenario? Well, if so, you might find that the data mesh to be of particular interest to you. So what is the data mesh? Well, it can be neatly summarized in 4 main principles that we will go over in further detail in the following slides. But firstly, at a high level, Principle 1 addresses the difficulty in having this siloed, centralized data team by distributing the ownership of data back to the people who know it best, back to its domain. And this yields this domain-driven architecture. One further note on this topic is that this domain-driven concept is not new. In fact, this concept has been a huge success in the way in which we build software through microservices. So why not take the same idea and apply it to how we serve data? Anyways, moving on to Principle 2. This reminds us of the successes of product thinking and that we should adapt this same mentality to the design, the delivery, and the accessibility of the data that we serve to our customers, which is, the rest of the organization, by delivering data as a product. Then, through Principle 3, this helps us move away from having this hyper-specialized central data team that's usually burdened with providing data that they're unfamiliar with, by instead having that team focus on the enablement of self-service analytics by providing the infrastructure to do so as a platform. And lastly, Principle 4 remediates the general concern that you'll hear with the decentralization of this data ownership by implementing governance strategies and emphasizing the interoperability of the infrastructure to truly build an ecosystem of data products. Okay, now, these are the 4 principles as they have been presented and discussed, which is usually from the perspective of delivering and maintaining operational data. However, we want to discuss the data mesh from the perspective of what happens after the operational data mesh has matured. How does analytics fit in? So, well, after thinking about how these principles could be applied from the analytics point of view, we've come to realize that in addition to adapting product thinking into how we deliver data, that same thinking applies beautifully to how we deliver analytics. And that in order to be successful in doing so, we must also treat analytics as a first-class citizen, and therefore have the analytical needs of the organization at the forefront of the enterprise-wide strategy and design. So, as a result, rather than focusing on data as a product, we'll be spending the rest of our time discussing what it means to treat analytics as a product within this domain-driven architecture. So, what do we mean by domains? Okay, well, think of domains as a sphere of knowledge or influence or activity. Usually your domains line up pretty well with how your organizations are already naturally composed by functional unit. So here we have a pretty rough, high-level example of how a subset of domains and their data products could operate within healthcare. So first, we have our claims team that they maintain the claims database and they keep a historical record of all the claims events that come through. Then you might have a customer relations or patient relations team that uses a CRM like Salesforce to track a master list of all customers that the business has interacted with. Furthermore, you'd likely have an accounting team using an ERP like NetSuite to keep track of all the transactions and the contracts that you might have with providers and insurance companies. And this is not to say that these are the only data products that would be produced by these teams. Far from it. There could be dozens of ways to serve up this data and multiple views. But for the sake of simplicity, let's just hone in on these three theoretical data products. Okay, so in this domain-driven architecture, these domain teams are entirely responsible for ensuring a consistent and accurate data product, regardless of its use downstream. Now, this decoupling of the generation of data products, addresses a major failure mode of the traditional platform architecture by decomposing it into components that can be deployed independently, yet are functionally cohesive. So, as a result, a billing domain, which uses data products from other domains, can trust that the data that's feeding into their invoice data product will be consistent, and that they should only be concerned for what they are responsible for, in this case, generating invoice. So what makes up a domain team? Well, in order to empower the domain to be self-sufficient and to take ownership of their own data products and analytic assets, we must augment the team capability by embedding data engineers, analysts, and scientists who can work closely with the domain experts to build data pipelines, visualizations, and machine learning models. So it is also important that there be a product owner within each of these domains who is responsible for the life cycle of the domain data sets and analyses. And we'll touch more upon this product owner in a bit. But anyways, if you're still having trouble nailing down this concept of domains, it might help to think of them as usually one of two types. First, you typically have your domains that are aligned with the source of data, which in the previous example included the claims domain, the customer domain, and the accounting domains, as they tended to focus on blending and serving data for analytics directly from the source systems, like Salesforce and NetSuite. Then, on the other hand, you'll have domains that are more aligned with how the business tends to view or consume the data, such as with the billing domain that leveraged the source domains to develop billing-specific analytics. And in addition to that, you could also have domains that aggregate data from multiple source systems for easier reporting. For example, if in that healthcare case study, we received our claims events via two methods. Maybe we get some claims from online and some from a call center. Well, you could theoretically have a domain for each one of these source systems, and then a higher level domain that aggregates all of this data into one larger claims domain. But, one more thing I want to call out here is that you should define domains in a way that is appropriate to the scale of your business. Smaller organizations that have to deal with fewer resources may opt to group relevant domains and prioritize tasks based on level of impact, while larger organizations might just be able to allocate more resources and have more granular domains. But overall, the modeling of your organization around these business domains can decouple related processes while also enforcing accountability. And that's a very important topic. But moving on, coming back to this concept of analytics as a product, what we mean by that is that instead of treating analytics as a byproduct of the data that you're producing, you should really think of it as a product or a service that you are providing to your customers across the whole organization. And so, what makes an analytic asset truly a product? Well, it must be discoverable. Ideally, this would be through implementing some sort of data catalog that can help users find the analytics that is relevant to them, as well as enabling them to be able to understand the lineage of the data that's being used in these analyses. And each of these analytic assets should be and must be available on the centralized data catalog so that their customers can find them. Moreover, the analytic asset should be self-describing and easily understood by customers with clear documentation using common semantics. The analytic asset must also be secure to ensure that access is only being granted to the appropriate resources that should have it. And this security aspect should be considered for each individual analytic asset. And very importantly, the analytic asset should be trustworthy in order to ensure their adoption. A lot of time, the transparency into the lineage of the source data through this data catalog will help customers feel confident in the product. But additionally, any insight into how frequently the data is refreshed or, calling out any expected discrepancies will go a long way in gaining consumer trust. And lastly, the product must be governed by global standards and conventions to reduce confusion in having differing definitions of metrics or business keys. This helps with the interoperability of analytics and helps folks to be able to quickly plug and play with new data. So, how do you manage all of this? Well, with the decentralization of data ownership, it is important to maintain accountability. So as a result, there comes this whole new role in that of the domain product owner. And he or she are responsible for making decisions around the roadmap, prioritization, and governance of the domain analytic assets. A lot of time, this domain product owner must also act as the liaison between stakeholders and the domain team, and to upkeep customer satisfaction. And in order to do that, the domain product owner must track KPIs around the usage of these assets, their success, so that they can understand methods to improve existing products, or even to understand, when certain assets should be retired or no longer maintained. So by treating analytics as a product with the same oomph as we do with the data produced, we can create this culture of trust in data and analytics to finally become the data-driven organization that we've always been dreaming about. So how do we enable these domain teams to actually create these analytic assets? And what happens to the central data team? Well, rather than focusing on developing data pipelines without the domain knowledge and all the complication that brings, the central data team can instead focus on the infrastructure that will enable these domain teams to self-serve. So to do that, the central data team becomes the data platform team, whose main responsibility is to make analytics more efficient, regardless of the domain you're in, by facilitating and automating self-service capabilities. So in essence, their product is the infrastructure and not the analytics, removing the burden of understanding the intricacies of every data source and every data and analytic product. And as such, some of their responsibilities might include managing access control, user authentication, pipeline orchestration of common assets, implementing and automating governance and standardization policies, or even including alerting and notification capabilities for when there are errors or data quality issues. And similarly to how the domain team has a product owner, the platform team would also include a product owner. And this person would be accountable for the platform as a service, as well as delineating how domains are defined, as well as for the analytics of common elements that have shared usability across the whole enterprise. This platform product owner would play a major part in the network of product owners across the whole organization, where together they would all help create this federated governance strategy and communicate changes to their teams accordingly. Furthermore, similar to how the domain product owner is concerned with tracking KPIs about the satisfaction of domain analytic assets, the platform product owner must understand and be evaluated against how well the platform is meeting the demand of its users, as well as the platform fitness. So in the end, by making it easier for users to bootstrap their own analytics and self-serve, the infrastructure team can finally receive the appreciation it deserves by reducing the time it takes to generate analytical insights. Now comes the tricky part of decentralization. How can we ensure that these different domains that are now operating independently and producing their own analytics, that they don't end up separating into further silos? Well, our vision on how to achieve this is through the Analytic Center of Excellence, which we'll also refer to as the Analytics COE. And this group ultimately provides oversight of the implementation of enterprise governance policies and standards across all analytical products. And an important aspect of asserting governance is through the training and upskilling of users on data modeling and visualization best practices. And through this upskilling, the COE can certify users to ensure that tool licenses are being distributed to those who are skilled to use them, and can also support members who may be interested in going down different skill journeys. But building an ecosystem in data-driven culture is a complex process that is fundamentally about the people who practice analytics and the processes that they use to do so, rather than the technology. However, having the right toolset can provide a great foundation on which to build this culture. So, through having a data catalog such as Alteryx Connect, you can enable discovery of analytic assets, you can spotlight full projects, and you can identify stale artifacts that might need to be archived. Furthermore, the COE can add another layer of instilling confidence in analytic assets by certifying assets that meet governance standards, that are accurate and just also generally just meet product requirements. So, through fostering this cross-organizational culture of analytics, we can stand up a community of practice across the entire organization to encourage collaboration and to share collective learnings, rather than implementing top-down directives. And now I will pass it over to my teammate Jamie so that he can go into further detail as to why we believe that the SMALT Stack is uniquely suited to enable self-service within the data mesh and its principles. Thanks.
Great, thank you, Carolina. As Carolina has described, there are 4 principles that are really central to this data mesh kind of theory. The SMALT Stack brings together some of the best modern data and analytics tools in a way that we feel addresses each of these 4 principles. What I'm going to do in this section of the presentation is to walk you through the 4 layers of the stack. If I could have the next slide, please. Thank you. Okay, so the 4 layers of the SMALT Stack are discovery, analytics, orchestration, and the data cloud. At the top of the stack, we have the discovery layer, which is represented by Alteryx Connect. Connect is where we address 2 of the key principles of a data mesh strategy: analytics as a product and building an ecosystem around data and analytics. Using Connect, an organization can ensure that their analytic assets are discoverable, well documented, and they can use features like certification to mark that they're compliant with whatever governance policies they've put in place. Connect also, really importantly, brings together users to collaborate and discuss the analytic products, both within their domain and across an entire organization. Next, we have the analytics layer, which we've subdivided into analytics automation and analytics visualization. Alteryx Designer represents the analytics automation piece in that it provides a self-service platform that analysts can leverage to quickly develop new analytic products. Tableau represents the analytics visualization piece, again, leveraging easy-to-use self-serve tools for developing and sharing insightful dashboards and reports. Moving down the stack, next we have the orchestration layer. So as analytic products, such as a report that's gained a wide audience in a company, become more mature, there's often a need to fully productionize the pipelines that refresh and update the underlying data. This is where Matillion ETL comes in as a cloud-native environment where our pipelines can be built and deployed. Importantly, the visual nature of Matillion ETL enables the upskilling of data analysts, such as people who are familiar with Alteryx, to perform the types of tasks that might previously only have been possible using data engineers. This is all part of lowering that cost of specialization, which is another key aspect of the data mesh framework. Underpinning the stack, we have the data cloud layer, represented here by Snowflake. Snowflake, as I'm sure many of you know, was built for the cloud and has a pretty unique architecture where they've separated compute and storage, and this lends itself very well to being used within a data mesh environment. Different domains, who might ultimately all be using a shared Snowflake database for their analytic data, are never competing for resources and can size their warehouses according to their compute needs. The key thing that really brings all of these platforms together is that they've been designed to be user-friendly. They have low barriers to entry. And by leveraging this kind of self-service, low-code set of platforms, we think this is really the key to success when applying a data mesh strategy to analytics. So if I could have the next slide, please. So I'm going to take you through the tools within the stack now. I'm conscious of the time, so I'll probably summarize some of this a little. So Alteryx Connect represents our discovery layer in the SMALT stack. Connect is a collaborative data discovery platform for the enterprise. It empowers users to find, manage, understand, and collaborate on the data that resides both within their domain and across the organization. And that's a really key point because it's all about driving sort of standards across the organization and not creating new silos. Connect indexes many different types of data and analytic assets, including reports, workflows, and data sources, and can be used to maintain an up-to-date data catalog. It also has powerful collaboration features. It provides some insights into the relationships between analytic assets. As you can see now on screen, we're taking a Tableau dashboard, looking at what data sources feed into it, and then going a step further back and seeing the true lineage of that data. Assets that are trusted within an organization can also be certified, which gives us a traceable and transparent means of governing that data. So in summary, Connect is really one of the key ways that we address this challenge of building an ecosystem in a data mesh environment. But of course, as Carolina said, that goes hand in hand with the wider strategy of building an analytics center of excellence. Next slide, please. So moving on to the automation layer, Alteryx Designer is the cornerstone of Alteryx's analytic process automation platform. Designer represents this automation layer in the SMALT stack. What we're positioning this as is it's allowing data analysts to quickly develop, share, and iterate on analytic assets. So it's often the first place that these analytic assets will be developed. Designer allows the users to connect very quickly and directly to many different types of data sources. And this cuts the time that's taken to develop the first iteration of a product, such as in this example, a Tableau dashboard, which is being published from Alteryx directly into a Tableau server. But as I mentioned before, as analytic assets become more widely used, as they mature, you may want to sort of further productionize this process. And for those more mature products, moving elements of this pipeline into an orchestration layer makes a lot of sense and gives you big efficiency gains. Next slide, please. So next we have Tableau. Again, we're on this layer 2 of the stack, and this is our analytics visualization layer. Tableau is all about helping people see and understand their data. It has the same drag and drop interface that's common across many of these tools. And the key here is that it's got a great kind of integration with all of the other elements of the stack. It can use data prepared by Alteryx. It can connect directly to Snowflake data tables. And those data tables and views, of course, may have been updated using Matillion orchestration jobs. Analysts who develop charts and dashboards can then easily share those with business users, and they can interact using filters, using tooltips. So now we have the orchestration layer. This is a part I'm really kind of personally quite excited about. This is Matillion ETL, which is, in our view, where data pipelines that may have been prototyped in Alteryx Designer can be deployed into a fully cloud-native environment that has true deep integration with our data cloud layer, Snowflake. Matillion, in fact, was recently named Snowflake's Data Integration Partner of the Year, and it's been built as a cloud-native product that doesn't sort of move the data out of Snowflake. It all sits within Snowflake itself. And in fact, that's also a capability that we can leverage in Alteryx Designer. In the example I'm showing on screen, this is actually quite a cool feature. We've used components in Matillion to scale up the data warehouse at the start of an ETL process. So we're really interacting very directly with that Snowflake instance. Matillion, as you can see, has a visual drag and drop interface. And this is going to be familiar to people who've used tools like Alteryx. The key to this is that this simplicity of use gives us a lot of potential to upskill existing data analysts and Alteryx users to be able to perform tasks that previously would only have been possible using dedicated and expensive data engineers. This enablement of self-service data engineering through Matillion ETL addresses one of the key principles of data mesh around lowering the cost of specialization by leveraging self-serve platforms. Next slide, please. So finally, we have the data cloud layer, which is Snowflake. Snowflake really underpins this entire stack. And Snowflake, we think, is the best database to use in the cloud and to use with SMALT. On screen, I'm showing a query that's running using some data held within the Snowflake database. And what you'll know if you've used Snowflake is that it's incredibly quick. It's incredibly effective at dealing with different types of data and processing and handling that all very quickly. What I want to hone in on with Snowflake is this unique architecture where there's a separation of storage and compute, which gives us the ability to manage massive workloads and have concurrency between different teams or in data mesh, different domains without having any resource contention. So as a kind of data storage layer that underpins everything, Snowflake is a perfect fit for this data mesh paradigm. Snowflake also integrates pretty seamlessly with Alteryx, with Tableau, and indeed with Matillion. So, all of these different parts of the stack, I hope you can see, address different parts of the data mesh principles. And with that being said, I'll hand back over to Carolina for the wrap up.
Okay, thanks, Jamie. In summary, we discussed the common pitfalls of the monolithic architecture and how the data mesh addresses the challenges that arise from the centralization of data, people, and technologies by distributing the ownership of data and analytics, incorporating product thinking into the serving of data and analytics, as well as through the federated governance to ensure enterprise standards. And as Jean-Marc so neatly put it, in order for this architecture to be successful and scalable for organizations of all sizes and resources of varying levels of technical capability, the self-service toolset must lower the cost and specialization needed to perform analytics. And therefore, we believe that SMALT is the ideal stack for analytics within the data mesh due to its low barrier to entry to get started, how integrated the tools are with each other, and with their emphasis on self-service analytics. At Aimpoint Digital, we are a close partner with all of these platforms, and we have deep expertise in developing end-to-end analytical products, as well as in building a culture of analytics through our Center of Excellence offering. If you'd like to learn more about Aimpoint Digital or any of our software partners, please reach out to myself, Jamie Laird, or Ben Yop, and we'd be happy to assist you in any way we can. We thank you for spending time with us today, and I hope you all have a wonderful rest of the week. Thanks again.
Thanks, everyone. Goodbye.